All right, let's go ahead and draw the Lewis structure for formaldehyde, CH2O. Remember, let's count up all of our valence electrons. I get 4 from carbon. I get 2 times 1 is 2 from hydrogen, and I get 6 from oxygen. And so total, that's going to be 12 electrons. So the next step is to arrange the atoms as symmetrically as possible. I know that the carbon atom goes in the middle. And a symmetrical arrangement might look like this: 2 hydrogens there and an oxygen there. Now, there are different ways that I could arrange that. I can put 2 hydrogens there and oxygen there. That's no problem. I can put 2 hydrogens here and oxygen here. That's no problem. That's symmetrical. What I can't do is something like this. That's not very symmetrical. So we won't try that structure at all. So let's go back to our original structure: carbon in the middle, 2 hydrogens, and an oxygen here. Let's just shorten this guy up a little bit. All right, and now that I've got the atoms arranged, I want to draw one bond between every atom. Now, it's very important to draw only one bond and reduce your count of electrons by the number of electrons you used in those 3 bonds. So that's 6 electrons total. 12 minus 6 is 6, so I got 6 left. So let's take a look. Oxygen still needs an octet. 1, 2, 3, 4, 5, 6. Oxygen now has an octet. Hydrogen has an octet as well, but carbon is still electron deficient. So what do you do when you run out of electrons? You erase some electrons and you use them to make double bonds. So I'm going to make a double bond between the carbon and the oxygen with the 2 electrons that were on the top part of the oxygen. I still have 12 electrons on the page, but now everybody's got an octet: oxygen, carbon, and hydrogen. So I'm done with the Lewis structure now that I've used all of the electrons. Okay, so let's figure out the electron geometry. The electron geometry is where I'm going to count the geometry groups. Well, it looks like there's 1, 2, and remember, double bonds only count as 1 geometry group, 3 geometry groups. So the electron geometry is trigonal planar. Now, what about the molecular geometry? Now, are there any lone pairs? Well, the answer is no. And so since there aren't any lone pairs, the molecular geometry is the same as the electron geometry. So it's also trigonal planar. Okay, well, what are the bond angles? What are the bond angles? Remember that the bond angles go with the electron geometry. Trigonal planar electron geometry means 120-degree bond angles. Okay, is the molecule polar or nonpolar? Well, we can take a look at the molecule and we can see that the carbon is connected to 2 different types of atoms: hydrogen and carbon. We know that hydrogen is more electronegative, or is less electronegative than carbon. One more time, let's try this again. Hydrogen is less electronegative than carbon. So the individual bond dipoles for carbon and hydrogen point towards carbon. Similarly, oxygen is more electronegative than carbon, so the bond dipole for carbon-oxygen points towards oxygen. You can see that there is a net movement of all those dipole arrows that are generally pointing in the up direction. They don't all cancel out, so the molecule is polar. Okay, so that's all there is to this guy. We'll see you again.